The main differences between HTTP1 and HTTP2 are in the framing, which is how the request is actually kind of laid out on the wire, if you will. So let me start with this. If you have a current website and it's being delivered over HTTP1, there is nothing substantially different about HTTP2 that forces you to change your website. Like the semantics of HTTP are all exactly the same. You still have the get, the post, all the same, the headers, and all the rest. So the only thing that's different is how the request is sent on the wire, which, unless you're building a web server or the client like Chrome, like you don't really have to get into those details. But it turns out that those details actually matter a great deal when it comes to web performance. So as I mentioned, with HTTP1, the way it was defined is you have a connection. So let's say we negotiate connection to your server. If we send a request over that connection is occupied in the sense that I can't send another request over it until I get back the response, which is not great, right? So the way we kind of work around this is we open multiple connections. And for various reasons, that magic number seems to be around 6 for most browsers. So we will open up to 6 connections per server. So it means that we can fetch at most 6 resources at a time. Now, this worked well enough for a while, but it turns out that the web that was back in like 90s and the web that we're building today and applications that we're delivering are drastically different, right? The pages that we build today have hundreds of resources. And if we have this bottleneck of 6 requests at a time, then that is a performance limitation. This is why we start concatenating files and doing other things. So HTTP2 changes that, where it allows us to use one connection, and we can slice the request and responses into smaller chunks, which we call frames, and then just tag them with each one. Each frame is tagged with an ID that says, like, this bit of data belongs to this response. This bit of data responds to that response.
I see.
And we can send it all over the same connection. And this also affords us other flexibility, things like prioritization, where now we can also send hints to the server to say, hey, this CSS file is really, really important to me. And this image file, which I'm also requesting, is less important than the CSS because CSS blocks my rendering, image does not, right? So if possible, you should prioritize delivering the CSS to me. There's other capabilities like server push, where the server can actually send responses, multiple responses. So the best example for this may be you request the HTML page, and the server looks at the request and says, great, you're requesting index.html, and I know that you're going to come back to me and ask me for jQuery and style.css, right? Like there's just no reason for me not to send this to you. So the server can actually initiate that unilaterally, which is quite interesting as well. And then in terms of other interesting features, compression. So compression for the headers themselves. So if you ever looked on the wire, kind of into the low-level bits of how HTTP is transferred, we talked about compression in terms of the response body. So you have like HTML, and you can compress it with gzip. But the headers of the actual request, that like the user agent, the cookies, and other things, those in HTTP1 are always transferred in clear text, in plain text, I should say. They're never compressed, which doesn't seem like a big deal until you realize that with cookies and other things, that actually adds up quite quickly. So HTTP2 introduced HPACK, which is the header compression mechanism that allows us to eliminate that overhead. So the way it works is, let's say we have the user agent header, right? So it's this like very long opaque string that like, I'm a gecko, which is like Microsoft, which is like Apple, which is like Chrome string, right? Which is effectively what it claims. And today we send that on every single request. Now, guess what? That string doesn't change much, like between most of the requests, right?
Right.
Once a new release is out, like there's like a tiny change in it. So with HPACK, we can send that string once at the beginning of the connection, and then anytime we want to use it, we just kind of reference it as an ID and say, like, by the way, my user agent is still 5, right? Where the other client knows that 5 means that other string that was sent previously. So it really reduces the latency. And you get the benefit of smaller requests, you can multiplex requests, you can prioritize requests. It allows the server to be much smarter in how it responds with the data, and it allows the server more flexibility in how it sends the responses, so things like server push. So the combination of all those three allows for some pretty nice wins in some cases.
then do we still need to concatenate files to minify them and to do all these other tricks that we have been doing as developers to speed things up?
Yes and no. So minify, yes, right? So minification is, in effect, content-aware compression. Where, let me give you an example. Let's say I have a JavaScript file, and because I'm a good developer, I've put a lot of comments in it, right? Such that my fellow developers can look at it and understand what I'm doing. Now, it turns out that comments don't affect running code. Hopefully they don't. So there's no reason to ship comments, right, to production. But those comments do take bytes. Like if you actually
Right.
take, since we've used jQuery as an example, jQuery has extensive documentation.
Mm-hmm.
And if you look at the original version with comments and then the minified version, the biggest difference is they strip out the comments. And turns out that's like 50 kilobytes of data compressed, right? Because they have a lot of comments in there.
Yeah.
So that's an example of minification, even before we get into kind of more interesting and advanced use cases like shortening variable names and doing other stuff. Just removing the comments from jQuery is like saving tens of kilobytes. So minification still makes perfect sense. Things like concatenation starts to become more interesting, where the short answer is mostly not, right? So in the past, we built a lot of infrastructure and developed best practices for concatenate all your files into one script.js or one style.css. And that has its downsides too, as it turns out. Like say you have jQuery and your code and you put them together, then you update your code. Now you have to ship jQuery again, right? Even though
Mm-hmm.
jQuery hasn't changed. So that's not great. So you want to unbundle those. But then if you unbundle them, you run into the same problem of we can fetch at most 6 things at a time, which may or may not be a problem for your particular application. So there's always this trade-off, and you're not quite sure what to do. HP2 changes that in the sense that it removes this bottleneck of 6 requests. You can actually send hundreds of parallel requests. There's no
Mm-hmm.
issue with that. Now, does it make sense to ship like 101 kilobyte JavaScript files? No, probably not, right? Because that's like, the question is, can you get any benefit from bundling into larger buckets? Like if you know that 2 components are always used together, you can still put them together, unless there's going to be high churn in one of them.
Mm-hmm.
So you don't need concatenation and bundling as like a must-have with HTTP2.